You know, the ledger of truth for your entire system, it has to be immortal. So welcome to Module 5, Database Architecture. In this explainer, we are diving deep into the absolute heart of any mission-critical system. We're going to explore the sovereign ledger, the planetary mesh, and get to the bottom of why choosing a database, between Spanner, SQL, and NoSQL is probably the most permanent, high-stakes decision you'll ever make. Let's jump in. And let's be totally clear about the stakes, right from the get-go. If your database fails, your empire fails. It's really that simple. Every single decision we talk about here has consequences that just ripple across your entire operation, hitting your performance, your reliability, and ultimately, your bottom line. So this gets to the heart of it, right? Why is picking a database the most permanent choice you're going to make? Well, think about it. You can swap out a web server pretty easily or, refactor a microservice. But moving terabytes or, heck, petabytes of live transactional data from one database to another, that is not a weekend project. It is a massive, risky undertaking. It's like the foundation of your house. You can't just change it without tearing down everything built on top of it.
Okay, so to tackle all this, here's our game plan. First, we'll dig into why it's such a permanent decision. Then, we'll get into these really cool concepts, the sovereign ledger and the planetary mesh. After that, we'll hit the nitty-gritty of choosing your database, figure out how to bridge the legacy gap, and finally, wrap it all up with a roadmap for building an immortal state.
Right. Let's start with the real weight of this decision. These architectural choices, especially around your data, have an incredibly long half-life. The decisions someone made years ago are probably still dictating how your systems run today. And that's exactly why writing these things down is so critical for the long haul.
And here's how you manage that permanence, with something called an Architecture Decision Record, or ADR. Now, what's so cool about this is that an ADR isn't just some boring technical spec. It's about building a collective memory for your team. Imagine you're a new engineer, 5 years from now, and you're staring at some weird, outdated component. Without an ADR, you're totally lost. But with one, you see that choice was made because it was the only thing compatible with the key partner back then. All of a sudden, that bad decision makes perfect sense.
Okay, so this whole idea of making smart, lasting decisions leads us straight to our next big idea, the sovereign ledger. In today's world where your data lives and who can touch it, well, that's not just a tech question anymore. It's a legal and political one. Your database, your ledger of truth, has to play by the rules of the land. So here's the bottom line. Data sovereignty means your data is subject to the laws of the country where you collected it, and this changes everything, from where you can physically stick your servers to how you're allowed to process that information. For any business that operates across borders, getting a handle on this is completely non-negotiable. And getting this right is about more than just picking a cloud region. It really stands on 3 pillars. First, you've got data residency. That's the simple part, controlling where the data physically is. Then there's operational sovereignty, which is all about who gets the keys to the kingdom. For instance, making sure only personnel with specific citizenship can access certain data. And finally, software sovereignty, which gives you the control to run your stack wherever you need to, on-prem, hybrid, you name it. You know, that idea of being able to run your software anywhere is the perfect lead into our next topic, the planetary mesh. I mean, our apps serve people all over the world, so we need an architecture that isn't trapped in one data center or even one cloud. We need something that literally spans the planet.
So what is a planetary mesh? Think of it like a giant web that stretches across all your different environments. Your own data centers, Google Cloud, maybe other clouds too. It lets all of your systems talk to each other like they're in the same room. It just breaks down all the silos and creates one single logical system that operates globally.
And this is how it all comes together. We use distributed services, maybe running on Kubernetes, that can be spread all over the world. Then we use global load balancing, which is like a super smart traffic cop for the internet, to send users to the closest, fastest endpoint. And we tie it all together with secure, high-speed network connections that make all these different places act like one. So, you've got this grand vision for a sovereign, globally meshed application. Fantastic. Now we get to the absolute heart of it, choosing the database. And this is where we run smack into one of the most classic trade-offs in all of computer science.
So, you have 2 main camps. On one side, you've got your traditional SQL databases. They give you these ironclad guarantees, like strong consistency, which is awesome for things like finance. But they can be a real pain to scale out. On the other side, you've got NoSQL databases. They're built to scale and to always be available, but they often do that by compromising on consistency. This is the famous CAP theorem dilemma. It basically says you can only have 2 out of 3 things: consistency, availability, or partition tolerance. You're forced to choose. Do you want perfect data, or do you want perfect uptime?
But what if you didn't have to choose? What if you could have your cake and eat it too? This is where a database like Google Cloud Spanner just completely changes the game. It's engineered to be globally distributed and to scale out just like a NoSQL database. But, and this is the incredible part, it still gives you that rock-solid transactional consistency of a traditional SQL database. For global apps that just can't compromise, this is an absolute game changer.
Of course, all this new tech is great, but let's be real. Very few of us are starting with a blank canvas. Most big companies have poured decades and millions of dollars into legacy systems like Oracle. So the real question isn't always how do we rip and replace, it's how do we integrate and modernize what we already have.
And you know what? There's a really clear playbook for this. First, you set up a secure, private link between your cloud environment and your Oracle database. Then, you can build all your modern, new, scalable applications in the cloud and just have them talk to your existing Oracle database over that connection. This way, you get to modernize your apps without attempting that terrifying, high-risk database migration on day one. Okay, we've gone through a lot of theory. Let's make this real. Let's put all the pieces together into a practical roadmap. How do you actually build this immortal state we keep talking about? It's all about creating a system with really clear levels of resilience, one that can survive failures, big and small. And it all comes down to picking the right deployment type for the job. This table lays it out perfectly. A zonal deployment, think of that as your dev/test sandbox. It's cheap and easy, but if that zone goes down, so do you. Stepping up, a regional deployment gives you high availability within one geographic area, but it costs a bit more. For real disaster recovery, you need to go multi-regional to survive an entire region going dark, but that adds complexity. And at the top, a global deployment gives your users worldwide the fastest possible experience, but it's the most complex to run. The key takeaway, there's no one-size-fits-all answer. It's always a trade-off between availability, cost, and complexity. So in the end, it all comes back to this one simple fact. Your database is so much more than a place to put data. It's the definitive record of your business. It is the ledger of truth. And the choices you make around it, from the tech you pick to how you deploy it, will define its strength, its security, and its ability to carry your empire into the future.
The principles are here. The patterns are clear. The technology can do it. So the only real question left is, are you ready to build a state that never dies?